Hey guys, welcome back to the Kubernetes series. In the previous section of this series, we deployed Nginx to Kubernetes and we could able to access it with a stable IP address using services. In this section, we will be discussing how we can access the same Nginx with Ingress and how to secure our applications with HTTPS using Ingress with complete hands-on. So without any further delay, let's get started. As we discussed, one option to expose our applications outside of the cluster is using node port services. With node port services, we are opening a port on each node and exposing it to the outside of the cluster. The good thing with this is user can call any node IP in the cluster using that port and the request gets forwarded to the correct pod. But the bad part is the port's value must be between 30,000 to 32,767 and node IP may change on restarting the node and it's not secure to open ports on the node. To solve these problems, we have seen another option to expose our application to the outside world, which is load balancer service. This is preferred way to expose our application. But the bad part with this is it only works if you are operating in a cloud hosted environment like Google Kubernetes Engine or Amazon Elastic Kubernetes Service, etc. If you are on bare metal, we need to set up the entry point like proxy server. And whenever we create a service of type load balancer, a new load balancer gets created in the cloud. Please note that we have to pay for each load balancer that is created. So when we have multiple services, it will increase the cost and difficult to manage all these load balancers. Let's say we have two applications running. One is a simple to-do application developed with React.js and the other one is to-do API built with Spring Boot. When we expose these two applications with the load balancer service type, two load balancers are created in the cloud and we need to pay for these two load balancers. So what if there is a way if we have only one load balancer for all the requests and route it to different services based on the host or path? That's where Ingress comes into the picture. In Ingress, we declare which request should go to which service. So we write an Ingress rule that declares how you would like users to be routed to a service. In this example, we are routing todo.com to todo UI service and todo.com/API to todo API service. We call these mappings as Ingress rules. But writing these Ingress rules is not enough. There must be some component that reads these rules and processes them. That component is called Ingress Controller. Without Ingress Controller, just Ingress rules don't do anything on their own. So to process Ingress rules, we must deploy an Ingress Controller into our cluster to watch for these declarations and act upon them. So now, whenever we make a request, Ingress Controllers inspect HTTP request and direct that request to the correct pods based on the Ingress rule that we defined. For example, when we access todo.com, it first hits the load balancer. Then it goes to the Ingress controller pod and reads the Ingress rule and decides which service to call. Once it decides the service to call, it forwards the request to that service. And finally, it reaches the desired pods. And same thing happens when we call todo.com/API. Now we don't need any node port or load balancer services as Ingress controller is a pod and can access cluster IP services. So all we need to do is define cluster IP services for our applications. So now that we have a fair understanding of what Ingress rule is and what Ingress controller is, let's see Ingress in action. As per the official documentation, when we are running our Minikube cluster with a Docker driver, Ingress add-ons are only supported on Linux, meaning Ingress doesn't work that smoothly with Minikube using Docker driver on Mac and Windows. So I'm going to create a new cluster with a VM driver to demonstrate the Ingress. Please refer to the Minikube setup section of this series to know the different ways to create a Kubernetes cluster with Minikube. And if you are on Linux, you can continue with the same cluster whatever you use so far, that is Minikube with the Docker driver. So let's create a brand new cluster with the VM driver. Minikube start -vm is equal to true, and let's give a name to this cluster -t ingress cluster. As you can see, this is using hyperkit driver instead of docker driver. Cool, our new cluster is ready. Now let's run Nginx deployment and service files that we defined so far in this new cluster. kubectl apply -f nginx-deployment.yaml. The deployment is created. Let's run the service file as well. kubectl apply -f nginx service.yaml. The service also created. Let's clear the screen and verify if the pods and services are created accordingly. kubectl get all. As you can see, the 4 Nginx pods are running and Nginx service is also created, which is of cluster IP service. Now let us try to access this Nginx with Ingress. As we discussed, we need an Ingress controller to process the Ingress rules. So let's start by deploying an Ingress controller. There are many third-party implementations of Ingress controllers like HAProxy, Traffic, Istio, etc. I will put the entire list of Ingress controllers in the description of this video. But we have one implementation of Ingress controller which is maintained by Kubernetes itself, which is Nginx Ingress Controller. So let's use that one for demonstration. We can deploy this Nginx Ingress Controller in Minikube with just a single command. Minikube add-ons enable Ingress and our cluster name Ingress cluster. This automatically starts Kubernetes Nginx implementation of the Ingress controller. To verify if the Nginx Ingress controller is running or not, just run kubectl get pods -n ingress nginx. This -n denotes the namespace. Don't worry about namespaces for now. We will discuss about namespaces in detail in the next section of this series. As you can see, Nginx Ingress controller pod is running. So just like any other application, the Ingress controller is a pod and it gets exposed through service. kubectl get service -n ingress nginx. As you can see, a node port service is created for that Nginx Ingress controller. As we discussed, load balancer is not supported on Minikube. That's the reason node port service is created. If you are on the cloud, this should create a load balancer service instead of node port service. And this load balancer will act as an entry point to your cluster. I added the link in the description on how to install Nginx Ingress controller in the cloud. Awesome! Now we have our Nginx Ingress controller ready to process the Ingress rules. Now let us start writing Ingress rule to access the Nginx and then extend it to simple to-do UI and API applications. So let's open VS Code and create a new file with name nginx-ingress.yaml. Just like any other Kubernetes resource, for Ingress also API version, kind, metadata, and spec are mandatory. And as usual, we can find out this information with kubectl API resources grep ingress. So this is the API version and this is the kind and this is the short name for the ingress. So let's go back to VS Code and fill the values for these attributes. So this API version, kind is ingress. In the metadata, I'm going to give a name for this ingress rule, which is nginx-ingress. And this spec section contains the actual rules. So let's try to access this Nginx on nginx-demo.com. For that, we should give host as nginx-demo.com. And now we'll start writing the HTTP forwarding to the service. So here HTTP, and under this we are going to define the paths. So paths is an array, meaning we can write multiple rules for this nginx-demo.com. Enter path. As I'm going to access this Nginx on nginx-demo.com, I'm going to give this path as just /. We will see the other use cases in the next example. So for every rule, path type is mandatory. So this path type can hold any of the following values, which is implementation specific, exact, and prefix. Implementation specific meaning the path type is decided by the Ingress controller, whereas exact meaning the URL should match the exact path with case sensitivity, and prefix meaning the URL should match the path split by the slash. If you go through these examples, you will get a fair understanding of the differences between these three. Let's say we give the path as /foo and the path type as exact. In that case, when you access the /foo URL, it matches. But when you access /bar, it will not match because it will match the URL exactly with the path. Also, if you try to access the URL as /foo/, then also it will not match because there is an extra trailing slash. So whenever you give path type as exact, the URL has to match with the path exactly. Whereas if you give the path type as prefix, the trailing slashes and content after the trailing slash are ignored. Please pause the video and spend a minute to go through this example to have a better understanding of the path types. So I'm going to give this as prefix. So now we should define to which service the request should get forwarded to when we access nginx-demo.com. That we can mention with backend. In the backend, we give the service name as Nginx-service. Please note that this name has to match with the name of your application service. Also, we should give the port number on which this service is running with port number as 8082. This is because our Nginx service is running on the port 8082 and our service name is Nginx-service. So now our Ingress rule is ready. So let's save it and apply it. So kubectl apply-f nginx-ingress.yaml. As you can see, the ingress is created. We can verify that with kubectl get ingress or just ing, because ing is the short name for the ingress. Enter. As you can see, this is the ingress name and this is the ingress class, meaning this is using Nginx Ingress Controller, and we are trying to access this on nginx-demo.com, and the address is empty because it will take some time to assign the address to this ingress. So in general, this address would be the IP address of your load balancer. So let's try to list down the ingress again to see if the address is assigned. As we are on the Minikube with VM driver, localhost is assigned as the address. But as I said, in general, this should be the IP address of your load balancer. So now let's go back to the browser and try to access nginx-demo.com. So let's go to the browser and try to access nginx-demo.com. As you can see, the site can't be reached. This is because nginx-demo.com is not a valid DNS. When we type in any DNS in the browser, it should resolve to some IP address. Nginx-demo.com should resolve to the Minikube IP address. So we can get the Minikube IP with Minikube IP-p ingress cluster. So this is the Minikube IP address. So we should map the nginx-demo.com to this address in our machine. That one we can define by editing /etc/host file, and we have to update this file with root permissions. So once you open this file, come to this line and start editing this file by hitting I. So the insert mode is activated. Press enter and type in the Minikube IP address that we got, which is 192.168.64.10 space nginx-demo.com. So all we are defining here is nginx-demo.com should resolve to 192.168.64.10 which is minikube IP address. So let's come out of the insert mode by hitting escape, and let's come out of this file with colon WQ. The WQ stands for write and quit. Enter. So now let us try to access the nginx-demo.com again. Awesome. Now we are able to access our Nginx application on the custom domain. Now let's try to extend this ingress to access our TODO UI and API applications. So this is the configuration file which holds the deployment and service configuration for the UI and API applications. So as you can see, we are pulling the TODO-API image from the Docker Hub, and we are creating the deployment which creates the two replicas of the API application. Also, we are creating the TODO API service to access that API application. In the same way, we are creating a deployment for the TODO UI application. And in the same way, we are creating a TODO UI service to access that UI application. So let's try to run these TODO UI and API applications. I'll be adding a link to this file in the description of the video for your reference. So let's go back to terminal and kubectl apply-f TODO UI API.yaml. As you can see, TODO API deployment and TODO API service, TODO UI deployment and TODO UI service is created. Now we should access these two applications using Ingress. So let's go back to VS Code and start creating a new file, which is TODO Ingress path-based.yaml. So let's try to copy paste the same YAML file that we defined previously and try to modify accordingly. So here, let's change the name to TODO Ingress path-based, and let's try to access this one on the todo.com. So in the path, I'm going to add a wildcard which is .star. So here we are mentioning anything with the todo.com / should match to this rule, and the path type is prefix. And when we access this should go to TODO UI service that we just created, and our TODO UI service is running on the 3001 port. Perfect. So this is the ingress rule for the UI application. Let's try to add another rule for the API application. So copy paste, and here let's try to access the API with todo.com /API/. And whenever this rule is matched, let's forward this request to TODO API service. And the TODO API service is running on port 8080. Save it. And we have to add an annotation here, which is rewrite target. So what we are defining here with this annotation is any characters captured by this .star will be assigned to the placeholder, which is $1, which is then used as a parameter for the rewrite target annotation. For example, when we try to access todo.com /API/API todos, then it rewrites to todo.com /API/todos. So whatever the /API which we are defining in the path, that is just used as an identifier to this rule, and it internally rewrites to some other URL. So now our ingress rule is ready. Let's try to apply this. kubectl apply-f todo ingress path-based.yaml. Cool. The ingress is created. Let's verify that with kubectl get ingress. As you can see, the ingress is created. So now let's add this todo.com DNS entry in the /etc/host file. So sudo win /etc/host password. So let's come here. todo.com. Escape, write and quit. So now let's go back to the browser and try to access todo.com. As you can see, our TODO application is up and running. Also, we are able to get the data from database, meaning our API service also we are able to access it. We can verify that with todo.com /API/API/todos. As you can see, we got the data from database. Perfect. So this is called path based routing, meaning based on the path we are routing it to different services. So instead of accessing this UI and API on the same host with different paths, we can access this UI and API on the different hosts. So let's try to access this UI on the todo-ui.com, and let's try to access API on the todo-api.com. So let's try to copy the same file and see how we can do the host based routing. So host. So all we need to change here is instead of todo.com, todo-ui.com, and let's move this one to a different host, which is, let's try to copy the same thing and paste it here, and this is todo-api.com, and let's change the ingress name host based, and we don't need this wildcards anymore because this is host based, and we don't need to rewrite the target also. That's it. Now we are accessing UI application on the todo-ui.com and API on the todo-api.com. So let's go back to the terminal and apply this kubectl apply -f todo ingress host based YAML. Perfect. This is created. So let's add this DNS entries in the host file. Enter the password, insert mode, todo-ui.com and todo-api.com. Please note that all these domains are resolving to the same load balancer IP. Escape, right and quit, open the new tab, todo-ui.com. As you can see, we are able to access our application on a different host. And let's try to access our API with todo-api.com/API/todos. As you can see, we got the same response. So this is called host based routing, meaning based on the host, we are routing it to a different service. So as a summary, with the Ingress, we can route it to different services based on the path or based on the host. And when we try to describe the Ingress with kubectl describe Ingress Nginx-Ingress, we will see something called default backend, meaning when you try to access this Ingress, if none of the paths matches the URL, that request goes to default HTTP backend service. This is helpful for custom error messages. If none of the host or path match the HTTP request in the Ingress rules, the traffic is routed to this default backend. To make this work, all you need to do is define a service with the name default HTTP backend and connect it to the corresponding pods. You can do this on your own as a practice. Now let us see how we can secure our application with HTTPS using a TLS certificate with Ingress resource. For that, we need to generate a self-signed certificate and private key with OpenSSL. So here we are trying to generate our self-signed certificate. So let's request the certificate of type x509, and we need a new key which is of type RSA and length of 4096 with SHA 256 algorithm, and we don't need any password. And let's write the key to tls.key file and certificate to the tls.crt file, and our target domain is /cn, which stands for common name, is equal to nginx-demo.com, and this expires in 365 days. Enter. So now this generated a self-signed certificate. Now we should give this self-signed certificate to the Ingress rule. For that, we need to create a secret. Don't worry about secrets now. We have a separate section for that. So let's generate the secret with kubectl create secret TLS and the secret name which is nginx-demo.com. So the general naming convention for the secret is host name with the suffix of TLS and all the dots are replaced by hyphens. And the certificate is tls.crt and the key is tls.key. Enter. Now the secret is created. Now we can secure an ingress by specifying the secret we created, which contains a TLS private key and certificate. So let's copy the secret name and give it in the ingress. So this is the Nginx ingress. So let's give that here in the spec section. TLS secret name is Nginx-demo-com-tls and host we should mention, which is nginx-demo.com. That's it. Let's try to apply this. kubectl-f nginx ingress.yaml. So let's go back to browser and try to access nginx.com with HTTPS. As this is a self-signed certificate, we should trust this certificate. So if you click on advanced, you will see a proceed link here. If you are on Mac, just click anywhere and type this is unsafe. Then you will be navigated to the application. And we can see our certificate here with these certificates here, nginx-demo.com, which is a self-signed root certificate and expires after 365 days. That's all about Ingress. I hope you thoroughly enjoyed it. My name is Pavan Elthepu and I thank you very much for watching this video. If you liked it, please share it with your friends and do not forget to subscribe to my channel to not miss any updates.